Welcome to section 3.2 homework help. We're going to go over a couple of problems here to help you with your homework. And so we're looking on page 183, and we're going to start with number 1. And number 1, we have a function f of x is equal to 3x squared. Now, we are looking for f prime of x. And so to find that, we need to find the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so we can plug this in and say that when we put in x plus h into x squared, we know we have to expand the binomial x plus h, and so we're going to get a 3 times the quantity x squared plus 2xh plus h squared, and then we're going to subtract the entire 3x squared, and all of that is going to be over h. And let's not forget to take the limit of that as h approaches 0. Now, when we simplify here, 3x squared and 3x squared, that cancels, and then we get a 6xh plus 3h squared all over h. So we get the limit of 3 times the 2xh times the h squared all over h. Now, we can look and see that, well, h cancels with h, and it cancels with one of those h's, and this simplifies into simply, as h approaches 0, we know that this whole thing is going to 0, and we're just going to be left with 6x. So that tells us that f prime of x is simply equal to 6x. Now, moving on, let's jump to number 13. And number 13 tells us to use the function that we use in number 1. So the function f of x is equal to 3x squared. And we just found that f prime of x is equal to 6x. And we want to find what is f prime of a when a is equal to 3. So we simply have to plug that in. F prime of 3 is going to equal 6 times 3, which is equal to 18. So right there, doing number 1 and number 13 will help you out in doing number 2 with 14 and number 3 with 15. Okay, let's take a look at another one here. Let's look at number 20 on page 183. And number 20 defines y as equal to 5 over x plus 1. And we're asked to find two different things. First, in part A, we want to find what is dy dx. And part B, we simply want to evaluate dy dx at x equal to negative 2. Okay, so once we have part A, we can find part B just by evaluating, plugging in negative 2 for x. But let's find our first derivative here. And we do that from our limit. And I'm not going to write down the limit. I'm just going to skip right to it, knowing that the limit as h approaches 0, we want 5 over x plus h plus 1 minus 5 over x minus 1. Now, why is this a minus 1 and all of that is over h? Why is that a minus 1? Because we're subtracting the entire quantity of f of x. So we're subtracting a 5x and we're subtracting a positive 1, so that becomes minus 1. Now what that does is that cancels out with the positive 1 and the negative 1, and we want to subtract these here. We have 5 over this denominator and 5 over that denominator. So to find a common denominator between the two, we just have this times that. So the limit as h approaches 0, we have all of this over h, and our common denominator is x plus h times x. And what are we going to be left with here? Well, we have to cross this up into here, so we have 5x minus 5 times the quantity x plus h. And so we can do some simplification here. And the h is going to come up into the denominator, and so we're going to get the limit as h approaches 0 of, well, 5x minus 5x, that's going to cancel with that. And then we're going to get a negative 5h all over, well, down here we're going to have the x plus h times x times h, because remember, when we divide a quantity by another quantity and then divide that quotient by another quantity, that is the same thing as putting the third quantity into the denominator of the first. Okay, so these h's cancel, so those h's are gone, and we're left with the limit as h approaches 0 of negative 5 over x plus h times x. Well, as h approaches 0, this just becomes x times x in the bottom, so we get our dy dx to be a negative 5 over x squared. And that is our first derivative function. It's negative 5 over x squared. Now, in part B, we want to know, well, what is dy dx evaluated at x equal to negative 2? So we simply put in a negative 2. Negative 2 squared gives us a positive 4 because the negative 2 is being squared, so we get a negative 5/4 for our first derivative defined at x equal to negative 2. So one final problem we're going to take a look at is number 24. And in 24, they ask us to find dV/dr. Now this is a little different in that our variables here are different, and really the process is still the same. We're going to take the derivative of v with respect to r. Now we're taking dV/dr from the volume equation, that the volume is 4/3 pi r cubed. Now what's this volume talking about here? This is the volume of a sphere with radius r. We can find the volume as 4/3 pi r cubed. So we want to find what is dV/dr. Now that's going to happen when we take the limit as h approaches 0, and this time we're just plugging in, instead of x plus h, it's just r plus h, and instead of f of x, it's just v of r. So the process is still the same. We're simply going to put in the 4/3 pi times the quantity r plus h cubed minus 4/3 pi r cubed. And all of that's going to be over h. Now let's simplify things a little bit by expanding this binomial here. And we know when we expand that, we are going to get 4/3 pi out in front, and inside we're going to get r cubed plus 3r squared h plus 3rh squared plus h cubed. Now from that we are still going to subtract a 4/3 pi r cubed. I'm running out of room here, but all of that is going to be over h. And we can simplify this limit by saying the 4/3 r cubed is going to cancel out with 4/3 pi r cubed, so that's gone and that's gone. And what we're left with is the limit as h approaches 0. We still have this 4/3 pi out front, and in fact we could even move it out front of the limit because now we're multiplying everything by it, but we'll just leave it where it is for right now. And inside we have a 3r squared h plus 3rh squared plus h cubed. Okay, now all of that is over h. Now these h's cancel, and we still get an h there, and this becomes an h squared. And as h goes to 0, well, that goes to 0. So that term goes to 0, that term goes to 0, and we are simply left with the product of 4/3 pi times 3r squared. Now we notice the 3's cancel, and we get dV dr is simply 4 pi r squared. And those of you that remember your geometry formulas, that is actually something significant. The change in volume with respect to the radius, that gives you the formula for the area of a circle. So just something a little significant there, and we'll talk about more of that significance later.